Hi, today I'm going to talk to you about writing equations from a table. So here we go. Y equals mx plus b is the same linear equation from slope-intercept that we've been using. That doesn't change. The m stands for the slope, and the y-intercept is the variable b. So that is exactly the same as you've been learning with slope-intercept form from a graph. Nothing changed. All right, so let's take a look at a table. So we're going to find the slope from a table, which we've done previously, and you can use change in y over change in x, or you can use y2 minus y1 over x2 minus x1, whichever equation or whichever method you have been finding slope with, you continue to do that. So I'm going to take a look at this table, and I'm going to use the change in y over change in x. So I'm looking for what the change in each of these numbers is. So from -4 to 2 is a change of positive 6. From 2 to 8 is positive 6. And all the way down is positive 6. So my change in y is equal to positive 6. And I do the same on my change in x, see what's happening on this side. And it appears that in each of the intervals, I am adding 2 each time. So my change in x is plus 2. So when I put it together to find the slope, I put the change in y on the top and the change in x on the bottom, and then I reduce. So you can either say that the slope is 3 over 1, or you can say that the slope is 3. Both are correct. Now, for the y-intercept. The definition of the y-intercept is when x equals 0, what does y equal? So we're going to go to our table, and we're going to find when x equals 0. So here's our table with the column x, the x variables, and the y variables to the right. So we're going to scan down and find when x equals 0, what does y equal? Okay, so when x equals 0, y equals 2. So 2 is my y-intercept. And then I put it together in my equation. We always start with y equals, and it's y equals mx plus b. So the m is replaced with the slope, x plus b, which is the y-intercept, which is 2. All right, I'm just going to show you something quickly. And I want to show you what that would look like on a graph, because you have been finding the y-intercept and the slope from a graph and then writing the equation. So this is the table that you just discovered, we just walked through, and the equation is y equals 3x plus 2. So here's the y-intercept. It's where the line crosses the y-axis, or on the table, it's when x equals 0, what does y equal? And the slope is the change in y over the change in x, or the rise over the run. So the y-intercept's 2, and the slope is 3. 1, 2, 3, and over 1 to the right, 3 over 1, and then we're back on a perfect point. So the table represents points that would be on the graph. The points of the linear equation make up this red line. Okay. Just sometimes it's easier to work with the table. You don't have graph paper or the ability to graph something. So here you have your points, and you're going to pick out the y-intercept and the slope. Okay. Going to the next slide. Okay, these are exactly the same type of examples as the first one. So again, you're going to find your slope, change in y over change in x, and then you're going to look at the table and find when x equals 0, what does y equal? So if you want to pause the video and get those answers, that'd be great. Okay, so those are the answers. Our slope is our change in y over change in x. Our y-intercepts are when x equals 0. So you find the 0 in the table and you look and see what y would equal. Find the 0 when x is 0, y would equal 0. So that's your y-intercept. Now sometimes you're going to be given a table when 0 is not in the table. It still exists because lines continue off into infinity, and we are only listing a portion of the perfect points that would be on the graph. So we find our slope the exact same way. So we look for our change in y, and then we look for our change in x, and then we put it together, change in y over change in x. So our slope would be 5 over 1 or just 5. Both are the same. Now, there is no 0 in this table, so you have to extend the table so that it would include a 0. So I'll take a look here. So numerically, I'm looking at the x column, 0 would fall here. So it would go 0, 1, 2, 3, 4, 5. And that's still maintaining a constant rate of adding 1 on the x. So we have to go to the y column of our variables and maintain the pattern that's consistent, which is adding 5. So we want to fill this part in, fill this number in, so that what number plus 5 is going to equal 5. And that's how we maintain a constant rate of change. We're not changing the pattern, we're just extending the graph or the table. So what number plus 5 equals 5? Well, that would be 0. So then the definition of a y-intercept is when x equals 0. What does y equal? Well, x equals 0, y also equals 0. And then we put it together. Y equals, you can write 5x, you can write 5x plus 0, because when you add 0, that does not add any value to it.